Hi, today we're going to solve this question using integration by parts. Um, in the you use integration by parts in the case where you're not using u substitution. Integration by parts is used when you have two functions and those functions are not related. And when I say they're not related, I mean you can't use u substitution with those. One function is not the derivative of the other function. In the case that one function is the derivative of the other function, you can use u substitution. But in integration by parts is for those cases where you can't use u substitution. So usually when I have integration by parts, I use the tabular method. And the tabular method is a shortcut to this formula, which I'm going to write down right now. And it's integral of u dv is equal to uv minus integral of v du. When we are using this formula, it is important to identify the correct u. So to identify the correct u, there is an acronym called IPET. IPET stands for the I stands for inverse functions, P stands for polynomials, E stands for exponentials, and T stands for trigonometric. Inverse functions are always given priority. So if we have an integral with two functions and then one of those two functions is an inverse function, that inverse function will be your u. If the integral does not have any inverse functions and it instead has a polynomial function, then that polynomial function will be your u. And then if we have an integral with an exponential function and a trigonometric functions, then it doesn't matter. Those two are interchangeable. Either one can be your u in an if you're trying to solve an integral with an exponential and a trigonometric function. For this case, we have an inverse function. Our inverse function is ln of 2x plus 3, right? So that's our u. And our dv is going to be the rest of it, which is dx. Now I'm going to use the tabular method. So our u was ln of 2x plus 3, and our dv was dx. And in the tabular method, you write it like this, and the left side you differentiate, and the right side you integrate. It is basically this formula. And so I differentiate ln of 2x plus 3, and let's differentiate it over here. So ln of d of dx of ln of 2x plus 3 is going to be, so we know when we have ln of x, it's 1 over x, right? So this would be 1 over 2x plus 3. And then using chain rule, the derivative of 2x plus 3 is 2. So we'll multiply 2. So here, our once we differentiate it, it would be 2 over 2x plus 3 would be our different derivative. Okay. Then we're going to go here and we're going to integrate it. So dx is basically the same thing as 1 times dx, right? And when you have a constant, so let's say you had a constant 2 dx and you're trying to find, not constant, let's say you have an integral 2 dx and you're trying to find the integral of it, so then it would be 2x, right? So for this one, this is just the integral of 1 times dx, and this would be equal to x. Okay. So now we have our setup right here. And what we're going to do is we're gonna add the so this is we're going to multiply our uv, right? So this is basically our v, right? We integrated dv to get our v, and then we differentiated u to get our du. So we're gonna multiply uv, and then um, we get our then so like in from this, pardon me, from here we have the integral of u dv is equal to uv minus the integral of v du. So x is our v, and ln of 2x plus 3 is our u. So this is our uv, and then our integral of v du is v is x, and then we're going to multiply that to 2 over 2x plus 3, which is our du. And this is equivalent to our what we started off with, which was the integral of ln of 2x plus 3 dx. Now we know how to solve this integral. We did not know how to solve that other integral. That's why we needed to use IBP, integration by parts. But we know how to solve this integral. So what I'm going to do is, because I don't want to write this again and again, I'm going to first solve this integral out. So the integral of x times 2x, not 2x, pardon me, the integral of x times 2 over 2x plus 3 dx. Okay. So this is equal to the integral of 2x over 2x plus 3 dx, right? And now we're going to use some algebraic manipulation to make it easier. So if I do 2x plus 3 minus 3 over 2x plus 3 dx, this would be the same, right? Because 2x plus 3 minus 3 is equal to 2x. So I'm going to use that because that way I can separate it into two different integrals. And I can separate it like this. 2x plus 3 over 2x plus 3 minus 3 over over 2x plus 3 dx, right? And then let's move forward here. And then this is the integral of 2x plus 3 over 2x plus, okay, I'm not going to write that out. And then 2x plus 3 over 2x plus 3 is 1, right? And then 1 minus 3 over 2x plus 3 dx. And now I'm going to solve for each separately. So then 1 dx minus integral of 3 over 2x plus 3 dx. So the integral of 1 dx is equal to x. And now we're going, since we have a coefficient, to make it easier on ourselves, we're going to bring it outside. So it's going to be minus 3 times the integral of 1 over 2x plus 3 dx. And here we can use u substitution, because u substitution is easiest. So our u would be equal to 2x plus 3. Our du would be equal to 2 dx. And then I'm going to do du divided by 2 is equal to dx. So this would be equal to x minus 3 times the integral of 1, and our u is 2x plus 3, 1 over u. And then our dx, we decided, would be equal to du over 2. So we're going to put du over 2 here. And then we're going to bring out our other coefficient, which is now we have 1 over 2 also. So now we can bring out 1 over 2, and we can multiply it to the 3 there. So it's equal to 1 over u du, right? And here, now we know the integral of 1 over u. So it's easy. Our integral of 1 over u is ln of u. So we'll just do minus 3 over 2 ln of u. And now we're going to go back and we're going to substitute what our u was. And our u was 2x plus 3. So we have x minus 3 over 2 ln of 2x plus 3. Okay, so this was basically this was the integral part we were solving for. This was the integral of v du. This is what it's equal to. Now I'm going to go back and I'm gonna put it back where we started from, right? We started from here. So our x ln 2x plus 3 minus, and then this is the integral v du. So our v du was What did I do? Okay, let's go back. Okay, so x minus 3 over 2 ln of 2x plus 3. Okay, so our VDU was x minus 3 over 2 ln of 2x plus 3. Okay, now we're just going to go and we're going to simplify. So here we're going to distribute our minus signs, right? And so it will be minus x plus 3 over 2 ln of 2x plus 3. And we have a common factor, which is ln of 2x plus 3. So we're going to bring those together. And it will be x ln 2x plus 3 plus 3 over 2 ln 2x plus 3 minus x. And also we would add c because this is an indefinite integral. So there will be some constant which we don't really know. So this is an indefinite integral. So we always add c at the end once we solve for it. So from here we would take out our x plus 3 over 2 and we would take out the common factor, which is ln of 2x plus 3. And so this is what we would get. And then, because it's neater, I'm also going to go and give them a common denominator. X plus 3 over 2, I'm going to give them a common denominator. And when we get a common denominator, it will be 2x, right? Because 2x over 2 is equal to x. So 2x plus 3 over 2 ln of 2x plus 3 minus x plus c. And that is your answer. So I hope this was helpful and take care. Bye.